Welcome to The Explainer. Today, we're tackling a huge debate that's happening at the very heart of AI research. It's a real clash of titans, and it's all about one big question. Is the whole AI revolution we're seeing built on a foundation that's actually a dead end? So, let's get right into it, because one of the biggest names in the field, Meta's chief AI scientist Yann LeCunn, he thinks the answer might just be yes. And look, this is one of the godfathers of deep learning we're talking about. So when he raises a red flag like this, you can bet the entire industry sits up and listens. And he is not mincing words here. He straight up says they're doomed. That is a heck of a statement. It's not just him saying, oh, there are some problems. He's suggesting that the entire architecture behind things like ChatGPT, it's not a stepping stone to something better. It's a cliff. Right. So this isn't just some minor academic squabble. What LeCunn is doing is throwing down a fundamental challenge to the way everyone is building AI right now. He's basically looking at the engine that's been driving this whole AI explosion and saying, hey, I think this thing is fundamentally broken. I mean, we've all seen these things in action, right? Tools like ChatGPT are amazing. They're super impressive. But what LeCunn is arguing is that this whole path we're on, just making these text prediction models bigger and bigger, it's never going to get us to real human-level intelligence. Not even close. Okay, so what is the problem, really? I mean, these tools are so powerful, how could they possibly be doomed? Well, LeCunn points to some really specific core limitations in how LLMs are built. And he thinks these aren't just hurdles we can overcome, he thinks they're brick walls. First off, they are just unbelievably data hungry. Think about it. A kid learns about the world through all their senses, right? Sight, sound, touch. A toddler sees a cup fall off a table once, and they get a pretty good intuitive grasp of gravity. An LLM, it has to read about that concept millions of times. Because the actual amount of information in text is, bit for bit, just tiny compared to, say, a video. And this next part was really the crux of the argument. The main job of an LLM, just predicting the next word, is, according to LeCunn, a deeply flawed goal. See, for any given sentence, there are tons of possible next words. The model makes a tiny little error in its prediction, then another on top of that, and those errors just snowball. That's how you get an AI starting a story that's perfectly factual and ending it by confidently making up something completely bonkers. Plus, it's just wildly inefficient. It burns the same insane amount of energy to answer what's 2 plus 2 as it does to explain quantum mechanics. That just doesn't make sense. Okay, so if LLMs are doomed, then what's the alternative? And this is where it gets really fascinating. LeCunn isn't just pointing out problems. He's proposing a totally different way of thinking about AI. And it's inspired not by language, but by how we as humans learn about the physical world around us. And this slide really lays out that philosophical divide perfectly. On one side, you have the current approach, just predict the next word. But on LeCunn's side, the goal is totally different. Predict the future state of the world. He imagines an AI that builds an internal world model. Basically, it learns the fundamental rules of how the world works, cause and effect, physics, you name it, mostly from watching video. And once it understands that, it can actually plan how to achieve a goal. So this leads to a completely different way of thinking. The system he's proposing runs in a kind of loop. First, it thinks about a few things it could do. Then, it uses its world model to simulate what would happen for each of those actions. You know, if I do this, then that will happen. Then, it figures out which outcome is the best one, and that's the path it chooses. It's way closer to how you might plan out your day or figure out the best move in a game of chess. Now, this isn't just some abstract idea he's floating out there. It's all backed by some really serious research. And that brings us to the actual blueprint for this idea, a new framework from his lab at Meta AI. It's called JEPA. Yeah, it's a bit of a mouthful, I know, but JEPA is basically the technical instruction manual for building these world models. And its number one job is to solve a really nasty problem in this kind of AI training, a problem called representation collapse. In simple terms, it's designed to stop the AI from getting lazy and just learning nothing. So what exactly is this lazy AI problem? Well, imagine you're feeding the AI all this incredible rich data, videos, images, you name it. If you're not careful, the AI can learn a cheat code. It figures out the easiest possible thing to do is just give the same simple, useless answer for every single input. It completely ignores all the nuance. Now, for years, researchers have tried to stop this with all these complicated tricks and, well, hacks. But those fixes were always really brittle and a huge pain to get working right. This is where JEPA has its big breakthrough. Instead of adding more complicated hacks, the researchers went back to first principles, back to the math, and they figured out that if you can force the AI's internal map of the data to have a very specific shape, think of it like telling all the data points they have to spread out evenly inside a sphere instead of clumping together in one corner, well, then it physically can't get lazy. It's forced to learn something useful. So they came up with this elegant new rule called SIGREG to do just that. And the result? A system that prevents his collapse by its very design. It's way more stable and way, way simpler to build. And get this. The actual core code that makes this powerful new system work, it's about 50 lines long. That's it. It just goes to show how radically simple and elegant this approach is compared to the clunky, hack-filled systems that came before it. So, what's the big takeaway here? What this all comes down to is that we're looking at two completely different futures for artificial intelligence. We are, right now, at a genuine fork in the road.
And this is the question, isn't it? Do we keep doing what we're doing, just building bigger and bigger language models and hoping we somehow push past their built-in limits? Or do we pivot? Do we start designing AI that actually tries to understand and reason about the world in a way that's much more like how we do it?
And look, this decision isn't just for academics in a lab somewhere. This is going to shape everything. The capabilities of these systems, their safety, the very nature of the AI that you and I are going to be interacting with every single day. So the outcome of this great debate, it won't just define the future of AI. It's going to help define our future with it.